So you are now equipped with some more tools in the define phase. Now your project charter is complete, and you're also annexing the SIPOC along with the project charter. So the sponsor will have better confidence on the team's ability. And as rightly explained by our Veer Raghavan sir, so it is a scoping tool. The SIPOC will help you to understand the project boundaries. All the stakeholders, you will be able to see them under the heading supplier and then customer. In SIPOC, S stands for supplier, C stands for customer. All the suppliers involved, all the customers involved are nothing but the stakeholders of your project. So you can involve them, you can actually manage them effectively to produce results from your project. Now let us get into our job. Now we want to understand some additional tools in the measure phase. So when it comes to data type, we initially, we know that there are basically two types of data available. One is continuous, the other one is discrete, right?
Discrete.
Even before classifying the data into continuous and discrete, there is another broader classification: qualitative data and quantitative data. Qualitative in the sense, no numbers. It is full of, what to say?
Objective.
Kind
Subjective
of,
statements.
subjective statements. Like even images, the photographs are qualitative data, right? So the photograph of above of the defect and photograph of a group of people or whatever. And similarly, the all the information represented without using numbers, all of them are known as qualitative data. But once you start using numbers to represent an information or to pass on an information, then the data should be called as quantitative. And in that quantitative, you have two types. One is continuous, the other one is discrete. Continuous means measurable and discrete means the countable, right? And I hope you all know that the discrete data always comes in the form of a whole number. Always in the form of a whole number without decimals. That is only an initial level of understanding. You can bring decimals even in a discrete data. Say, for example, if I allow you to rate the training program on a 5-point scale, and if I also give you, 0.5 as a rating and 1.5, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, and 5. Can you see decimals here? But still, this is coming under discrete only. Can somebody tell me why it is still considered decimal? It is not continuous. Because between 1 and 1.5, you don't have an option, isn't it? After 1, you only have 1.5. After 1.5, you only have 2. Totally from 0 to 5, how many values are made available for you? Tell me, 0 to 5. If I go in steps of 0.5, how many values are made available now?
10.
10.
10 enters.
So you can actually count all the maximum, possible values. Whenever you can count the maximum possible number of values, then the data type must be discrete. Suppose if it is not the customer rating, let us say it is diameter of a product, which can vary from 0 to 5 mm. Now, how many values are possible between 0 to 5 mm? Infinity. You can't say, 0.4 is not possible. 0.4 will come. In some product, 0.42 will come. In some other product, 0.424 will come. It all depends on the resolution of your measuring instrument. So infinite possibilities are there. That is why we call the data as continuous data. All of you, do you understand another way of defining continuous data and discrete data? Discrete data means only discrete number of values are possible. 10 means only 10 values will get repeated again and again. The 11th value will not come. But in a continuous data, infinite possibilities exist. All right. And there is one more way of classifying the data. One is known as nominal data. Nominal data. You know what is nominal data? Suppose if I write down all your names in a piece of paper, then the list of names I have is a nominal data. Why all of you have a name? Why there is a name given to each person? What is the purpose of name?
Identification.
Yeah, identification. Differentiating one from other, isn't it? So it is just helping you to differentiate one data from other data. For that purpose only, we use nominal data, nothing else. That means the usage of nominal data is differentiate one from other. That's all. Can you perform any mathematical operation using nominal data? Like for example, can I add Sadashiv and Sushant? Sadashiv plus Sushant is equal to, I don't know. There is no logic, isn't it? So mathematical operations are not possible with your nominal data. The sole purpose is to differentiate one from other. Do you have names for your product? Do you
Yes,
have
sir.
names for your machines?
Yes.
Yes, sir.
You have names. You have names for the product. You have names for the machines. Suppose you are an engine manufacturer. Every engine will have a name. That's known as engine number. Yes or no?
Yes.
That's called engine number. Even though it is a number, the purpose of the number is to differentiate one engine from other engine. Yes or no?
Yes.
So such data are known as nominal data. Even though there are numbers coming, the numbers do not have any actual meaning other than differentiating one engine from other engine. Can you tell me one example of nominal data from your industry? Just think about it and then tell me.
Name of the
You might be used.
customers,
Name of the,
customers and the valves.
that's all.
Product name.
Very good.
Product
Product
name.
name and name of the customers, right? And this you have, let us say you have 10 teams working under you, 10 teams reporting under you. Then you have a name for each team, isn't it? Like the World Cup match is going on. Every team has got a name, isn't it? So these are all nominal data. And there is another form of data known as ordinal data. Ordinal data. Here, in addition to differentiating one from other, you will also be able to arrange the number in a particular order, increasing order or decreasing order. You can always arrange the number in a ascending order or descending order. You can't perform any other mathematical operation. The only mathematical operation that is possible is you can arrange the number or the data in some order, ascending order or descending order. Suppose if I conduct an exam and assign a rank to each one of you, and first rank, second rank, and third rank, and so on. What do you understand? The candidate who got the first rank is the highest scorer, yes or no? And the person who scored next to him, he will be given second rank. But I don't reveal the marks, but I only reveal the rank. Now the data made available is an ordinal data. It's only an ordinal data, that's all. If I ask you what is the difference between rank number 1 and rank number 2, will you be able to find out?
No.
Without having the marks, you can't find out because you only have the rank, right? So these are known as ordinal data. Temperature, low, medium, and high. What kind of data it is?
Ordinal.
This is ordinal. So low means low temperature, medium means medium temperature, high means high temperature. So this is a kind of ordinal data. You no need to consider that as a nominal data. This is actually ordinal because it is helping you to arrange the data in some order. Can you give some other example for ordinal data?
Answers that can be given with like true or false, yes or no. These are also ordinal data, I think.
No.
Okay.
Now what is the order? Suppose you need to arrange the data in a particular order. How will you arrange with true or false?
No, sir.
No.
Yeah.
So that
Class
is
one,
in
two,
that
three.
1,
Class
2.
class 1, class 2, class 3. Like based on the criticality of the industry, the product
Okay.
range can be differentiated with class 1, class 2 kind of.
Okay, class 1 product, class 2 product, class 3 product, something like that. Maybe based on certain pricing or some other criteria, you have categorized as class 1, class 2. Then it indicates the order. Maybe first
Class
class
1 is
means
consumer products, class 2 is industrial product, class 3 is uh, military applications kind of
yeah.
stuff.
See, if it is only helping you to categorize, then it is nominal data. In addition to the categorization, if it is also helping you to understand the order. Say, for example, based on the value, certain items are classified as A class item, certain items are classed as B class item, certain items are classed as C class item. Now, the A class items are more valuable than B class. In that case, it is ordinal, right? So, you have,
ABC kind of parts in supply chain, like A
yes,
class item,
yes,
B class items.
that is ordinal data. But again, ordinal data, you can't perform mathematical operation. It's not possible. Then comes another form of data known as interval data. Now, in addition to differentiating one from other, in addition to arranging the number or the data in certain order, you will be able to find out the difference between any two number. You will be able to find out the difference between any two number. But addition, subtraction, addition, multiplication, division, all will not be possible. For example, suppose if you have a weighing machine, that weighing machine has a bias of 5 kg. So you stand up on the weighing machine and your weight is 65 kg. And I told you the equipment has a bias of 5 kg. So what will be the reading obtained?
60 to 70.
Of 60 kg. If your weight is, I told you your weight is how much? I told you
60.
65. And
65.
already there is a positive bias of 5. Yeah, positive bias of 5. So 65
positive means
weight,
2 7.
yeah. Now the
Six-
weight in the reading will be 70 kg. But what is the actual weight of the person? 65 only. But it is recorded as 70. Since there is a bias, the value is not the, what to say, true value. Why we are not able to get the true value? Because the datum is not 0. What is datum? The, what do you call, the origin? The 0
Reference.
point. 0 point is not there.
Well.
Very good. Since there is a bias, there is a 0 error. All straight away it is showing 5 kg. And so you add 65 kg, it becomes 70 kg. And now I am standing on the weighing machine. Let's say my weight is 75. When I stand up on the machine will give a reading of 80 kg. Because there is a positive bias of 5 kg, isn't it? So there are two readings obtained. One reading is 70 kg, the other reading is 80 kg. Now, with the help of the data, you are able to differentiate. The 75 kg, sorry, the 70 kg is your weight. The 80 kg is my weight. You are able to differentiate, isn't it? And then, if you have two reading, which is on the higher side, my weight is higher. You are able to arrange the data in ascending order and descending order. Will you be able to find out the difference in the weight between you and me?
Yes.
Yes.
What will be how will you find out the difference?
Your
But
weight
my
My
minus
reading is
our
80
weight.
kg.
All
Your
is
reading is
70,
70 kg. So the difference in the weight is 10
10
kg.
kg.
And what is the actual difference? My actual weight is 75. Your actual weight is 65. There also the difference is 10.
Yes.
Even my reading also allowing me to find out the difference correctly. So such data are known as interval data. The distance between any two data point can be calculated accurately with the help of the type of data known as interval data. Do you understand?
Yes.
All right. So even, but what is the limitation here? There is a bias. There is an absence of 0 point. There is an absence of 0 point, isn't it? So even if there is no one standing on the weighing machine, still the weighing machine will be showing how much? 5 kg.
5 kg.
So that means no, the 0 point is absent. If I bring the 0 point, if there is no weight, then the weighing machine will show a reading of 0 only. Now you have a true 0 point. 0 means 0. 0 means no object over the weighing machine. Now when the bias is 0, if a person of weight 65 kg stands up, what will be the reading? Exact 65. Another person of weight 75 standing, exact 75. Now you have two data points, but these data points are known as continuous data now. Or other name is ratio scale. Other name is ratio scale. You know, why do we call it ratio? I'll tell you. You can differentiate the data. You can you can arrange the data in order. You can calculate the difference. You can sum up the data. 65 and 75, what is the total weight? Sorry, 65 and 75, what is the total weight?
140.
140.
You and me together, we are weighing how much? 140 kg. This is also true. Summation also gives an accurate estimate value, isn't it? Which was not the case when you have data, biased data, isn't it? All of you are able to understand this point? When
The
you have
last
bias as part
No,
of your
sir.
weighting,
Could you could you, sir,
yeah, let
once
us go
again
to the
say that?
previous example of the, what do you call? The interval data.
Yes.
In the interval data, 65 weight is recorded as how much? 70.
70,
And 75 is recorded as how much?
80.
80.
80. Now I have two data points, 70 and 80. If I don't know that this data is, a kind of interval data, I simply use it for addition. What will be 70 plus 80?
150,
150. But what is the actual weight of, you and me together?
140, 140.
In place of 140, what are you getting? 150 you are getting.
Correct.
This is not accurate. This is the problem with interval data. This can be overcome by using the next form of data known as ratio data.
Okay.
Ratio means in addition to subtraction, addition also possible. All right. Suppose if your weight is 50 kg, my weight is 100 kg. I can say I am double the weight of you. Yes or no? The
Yes.
ratio is also meaningful. The ratio is also meaningful. My weight is double of you and you are half of me. All these, calculations are possible. That means you can not only add and subtract, you can also divide and multiply. That will have meaning. All mathematical operations are possible only with the ratio data. Clear, all of you? In ratio data, there will be a true 0 point. There will be a true 0 point. True 0 point means no object, no weight. Right? No object, no length. So length, diameter, thickness, surface finish, all of them are measurable with, true 0 point. So such data are known as ratio data. So how many types of data I introduced now? 4 types. What are the 4?
Nominal, ordinal, interval, and ratio.
Interval, ratio data.
Ratio. Suppose you want to perform all sort of mathematical operation. Which kind of data is preferable?
Ratio.
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 Now tell me, will you be able to convert the interval data into a ratio data?
If we know the bias.
Very good. Fantastic. You got the point. If you know the bias, calibrate your data first. Because bias is the amount of error that is present in your data. If you can clean your data and eliminate the error, then your data becomes ratio data.
Ratio data.
Otherwise, the data cannot be used cannot be, used for mathematical operation in the as it is condition. It can only be used to find out the difference and nothing else. Right? And you know the limitation of nominal data and then ordinal data. Nominal data, use it only for classifying or categorizing or differentiating one from other. Of course, the ordinal data, the order. So I think this is the knowledge you need to have, while dealing with the data. And when it comes to the statistics, again, ratio data is the best. If you are dealing with the ratio data, you can calculate average. The average will be very meaningful. The average will be a meaningful average. You know what is average, all of you, right? You just add all the data points, and then divide by the number of data points. That will be the average. If I have all your test mark, can I calculate average?
Yes.
Right? So once you calculate average, you can start making predictions. What is the prediction you can make with the help of average? Once you have an average, can you expect half of your data to fall above average?
Yes.
Can you expect half of your data to fall below average?
Yes.
Yes.
Yes, this is the property of normal distribution. Do you remember normal distribution? We talked about it, right?
Yes, sir.
So that will reflect in most of the cases. That will reflect in most of the cases, and importantly, with the ratio data. If you have a ratio data, even with the smaller number of ratio data, the normal distribution property will reflect. But suppose you are dealing with, let us say, the what do you call the nominal data, even like accepted, not accepted, true, false, and good, bad, these kind of things. If you have a large number of data, then there also you will be able to see normality. And if you are dealing with these kind of attribute data, of course, nominal data is a kind of can also be a kind of attribute data. So like accepted, rejected, right? So it's a kind of attribute data. And if you produce 100 parts, how many are accepted, how many are rejected? Let us say 5 get rejected, 5 got rejected. That means your rejection proportion is 5%. Your acceptance proportion is 95%. 100 people write the exam, 95 people passed, but 5 people got fail mark. And now the pass percentage is 95, fail percentage is 5. Now, what is this percentage? This percentage is known as proportion. This percentage is known as proportion. We calculate proportion for attribute data, and we calculate average for continuous or ratio data. Clear? When it comes to statistics, average is calculated for continuous data. Proportion is calculated for attribute or discrete data. Clear? And proportion also can exhibit normality. Proportion also can exhibit normality. That is why the normal distribution is found to be, extremely helpful. Imagine you have, yes, imagine, yeah, I have 10 coins. I have 10 coins. Now I toss all 10 coins. What is the chance for all 10 coins showing head?
10.
Very less
10,
chance.
10.
Very less.
Very, very less chance. Oh, see, I give you 10 coins and you have to toss all 10 together. Will you be able to get all hit at the same time? It's not that easy, isn't it?
No.
It is considered a rare event. Similarly, all coins showing tail also, rare event. So, the frequency of occurrence is less for all 10 heads or all 10 tails. If I bring down the number, let's say half of them are head, half of them are tail. Now the chances are bright. Yes or no? Now the chances are
Yes.
increasing. That means when I try 100 times, a good number of times, I will be able to get 50%, right? Half of them head and half of them tail. What I'm trying to say here is, if you try all possible, if you go for several number of trials, you will be able to, let me write something, you will be able to see the bell curve again getting formed. What am I writing here? 5H means what?
5 heads.
5 heads. If I toss 10 coins 100 times, majority of the time I will get 5 heads appearing while tossing a coin. Am I right? And I want to see 6 heads. Now the chances slightly decreases. Yes or no? I need 7 heads. Now the chances will further decrease. 8, 9. When I go for 10, it is very, very low. Since I am dealing with only 10 coins, the maximum number of head possible is 10 only, not more than that. Similarly, this side, this will be 4 heads or 3 heads, 2 heads, 1 head, and then no head. So the possible values are 0 to 10. And now, are you able to visualize now a kind of bell curve getting formed? But every point here is a proportion, isn't it? 7 head means 7 out of 10. 10 head means 10 out of 10. 5 head means 5 out of 10. Yes or no? So, proportion also can exhibit normality. Please note. Several cases can be dealt and the situation can be solved by applying the concept of normal distribution. That is my point. So that's why it is very, very important for all of you to understand everything about a normal distribution. If the inverted bell is nothing but normal distribution, isn't it? Should I erase this?
Yeah.
Okay. See here, I'm just drawing a bell curve. And at the center, this will be average, isn't it? And then any bell curve will have a spread equal to how much? Tell
3
me.
sigma. 3 sigma.
Total spread will be 6 sigma.
Sigma. 3
Half of the spread will be
3 sigma.
3 sigma this side, 3 sigma this side. And now when I consider the entire spread, what percentage of the data or what percentage of the population is expected to fall inside your control limit? These points are known as control limits, am I right?
Yes.
So inside the control limits, you can expect 99.73% of the population to fall within the control limit. 99.73% of the population can be expected to fall inside the control limit, provided you locate the control limits using an effective procedure. The procedure is the quality of the samples. The quality of the samples are good, your prediction will be more accurate. Yes or no? Ultimately, our interest is to understand the population. So, once the control limits are located, what percentage of the population is expected to fall inside the control limit?
99.7.
99.73. Suppose you don't want to work with the control limits. You want to go only up to this. And this point is x bar plus 2 sigma. Similarly, this point is x bar minus 2 sigma. And now these points are nothing but warning limits. What are these points? Warning limit. There is an upper warning limit and there is a lower warning limit. And now what percentage of the population is expected to fall inside the warning limit? 95.45%. 95.45%. These predictions will hold very correctly if you have proper quality of sample. Quality of the sample depends on your sampling technique as well as on the number of samples, right? So number of samples is also very important. Suppose I don't want to go up to the warning limit. Let's say I only wanted to understand what's happening only up to this point. And this point is X bar plus 1 sigma. And sorry. Yeah. So, and this point will be X bar minus 1 sigma. So you have 1 sigma minus 1 sigma here, plus 1 sigma here. And now what will be this percentage? 68.27 percentage. So what can you expect in your population? Can be predicted using the sample characteristics. All of you understand? See, in any scenario, we are interested in understanding the population. Am I right? What is our interest always? We are interested in understanding the population. So population will have certain behavior, or we call it, the characteristics. The population characteristics are known as parameters. You know what are parameters? The population average, which is mu, population average, which is mu, and then the population standard deviation, which is sigma. Why are we so much interested in average and standard deviation? Because once the average and standard deviation is known, everything is known. It is something similar to your horoscope. If I have your horoscope, will I be able to predict your characters? Professionals do it, isn't it? Whether you are a soft person, whether you are a good decision maker, all that, they predict. Similar to that, once I know the population average and population standard deviation, I can describe my population very well. You see here, look at my population. What is at the center? Mu. And what is the sigma? Sigma is this much. Once this sigma is known, it simply means maybe this is 2 sigma. And then this is 3 sigma. And beyond which not much exists. Can you see here? Not much exists, isn't it? So we are not interested in knowing what happens at this region. Because up to just by coming up to the upper control limit and the lower control limit, we are able to define 99.73% of the population. What are these mu and sigma known as? What is the name we have given?
Parameters.
Parameters. See, you do lot of analysis only to understand the parameters of your products, the parameters of your services. If your parameters are great, all your customers are extremely happy. Am I right? If your parameters are healthier, that means customer satisfaction is guaranteed. But if your parameters are bad, then there is a higher chance that your customers, can get frustrated frequently. Am I right? Okay. So see, most of the time, working with the population is not possible. Tell me which company will allow you to work with all the data. No company. So our majority of the situation, you will not have access to the population data. So what we do is, we decide to work with
Samples.
very good. We decide to work with sample. The difference between population and the sample is, here at the center, we will only have sample average. At the center, we will only have sample average. But what is your requirement now? With the help of the average, with the help of the X bar, you should be able to find out the mu. Yes or no? Now, how can you do that? You have to take the sample in a clever manner. How? If you can take only two samples, you must take one from here and another one from here. The second sample should come from the right side. Yes or no?
Yeah.
If I take one sample from the left side of the population, another sample from the right side of the population, then x bar can be more or less equal to mu. Yes or no? This
Yes.
is called a sampling technique. If you don't know this, you take both samples from this side only, then your sample average will appear here. Yes or no? That will lead to, a poor decision. All right. So when it is a sample, we have the distribution like this. There will be a sample average. And for the sample, the standard deviation is denoted by the letter S. Hereafter, don't use sigma for sample. You must use S. S is the symbol for sample standard deviation. And this may be 2S. And the maximum is 3S. And now this will be the upper control limit for your sample distribution. This is lower control limit. Here also the same rule will hold good. What will be the rule? 99.73. And when you take the two standard deviation, it will be 95.45. You take one standard deviation, 68.27. All of you are with me on this? Here, the X bar and the S, they are nothing but the sample average and sample standard deviation. They are known as statistics. The characteristics of the sample are known as statistics.
Statistics.
The characteristics of the sample should be called as the statistics. But why do we calculate statistics? To judge the parameters. We want to understand the parameter, so we work with statistics. Why? Because we only have access to the sample. Clear, all of you? Now,
Yes.
now I explained you two distribution. First one is population. Second one is sample. Now I want you to understand one more distribution, which is known as distribution of sample averages. Distribution of sample averages. In literature, it is also referred as sampling distribution. What are the three distribution? Population, sample, and the third one is sampling distribution or distribution of sample averages. I will show you how this third distribution will look like. What am I writing at the center?
X bar, X double bar.
X double bar. If this is X double bar means grand average. X double bar means grand average. What is grand average? Average of averages. Yes or no? Grand average is nothing but average of averages. That means in this distribution, every point on the distribution is a sample average. How many of you understand this? Every point on the distribution is not an individual point. It is a sample average. Do you understand? Let's say 8 o'clock, you take a sample of 3. Will you have an average? That will be X1 bar, isn't it?
Yes.
And 9 o'clock, your sample average is X2 bar. 10 o'clock, X3 bar. Likewise, the nth sample average is Xn bar. Every point is an average. And so the center point will be the average of the averages. All of it, you understand? We are trying to understand how the sample average is getting distributed. We are trying to understand how the sample average is getting distributed. And the beauty is the tendency of your sample average getting distributed in the form of a bell curve will be much higher than your individual samples. All of you agree with me on this? The tendency of your sample average exhibiting normality will be much higher than than the tendency of individual samples. If you plot individual samples, then the normality, you don't get the perfect normal bell curve. But if you have the sample average, you always take samples in group and then calculate the sample average and visualize the sample average, the tendency to exhibit normality is very high. This is a theorem known as central limit theorem. What is this theorem is telling you? The tendency of sample average exhibiting normality will be higher. It only depends on one factor. You know what is that factor? Sample size. What is the factor that decides whether the sample average can exhibit normality or not is sample size. If you simply increase the sample size, the distribution of sample average will definitely become normality. And what will be the sample size? Sample size will vary from 2 to 25 maximum. What is the sample size? 2 to 25. You just always take 2 samples at a time. If I take 2 sample, what is the value I will use it for visualization? Average of the 2 values. Then next 3 sample. So next 2 sample, again average, third average, fourth average. So every average here is an average of 2 points. If you are not getting bell curve, then you have to increase your sample size from 2 to 3. Now what will happen? You will get a better bell curve. Still you are not happy. You know what you should do? You should increase your sample size from 3 to 4. So if you keep on doing that, I'm sure definitely somewhere around 5 or 6. In rare cases only you may have to go up to 25. So just by incremental increase of the sample size, you will be able to get a smooth bell curve. All of you understand? But this curve is made up of sample averages. We call this distribution as what? Sampling distribution. All of you understand what is sampling distribution? Now what will be at the center? X?
X double bar.
Double bar.
Very good.
And average.
X double bar is average of the averages. Now, what will be this? This is nothing but the standard deviation of the points of your bell curve. What are your points? Averages, isn't it? Imagine you have taken 20 samples. Then how many average you will have? 20 averages. Please note, a sample can have 2 or more data points inside. Sample means a group of samples. It is better to use the word subgroup. See here, this is first subgroup, subgroup 1, and this is subgroup 2, this is subgroup 3, and so on. Let us say subgroup 1, there are 3 samples. And now the average of the 3 is here. Similarly, subgroup 2, 3 averages. If I have 20 subgroup, how many averages are possible?
20.
20 averages are possible. Now, can you type the 20 averages in a single column of an Excel? Now you have 20 data points, isn't it? Each point is an average. Can you calculate standard deviation of these 20 averages? That is known as standard error. That is known as standard error. So what is the definition of standard error? Standard deviation of sample averages. Do you understand, all of you? Why am I teaching all of this to you? Why am I teaching all of this? Because all of you wanted to understand your parameters. Yes or no?
Yes.
All of you are interested in finding out your mu. All of you are interested in finding out your sigma. But you all have only chance to deal with the samples. So my recommendation to you, or to all of you, is deal with the sampling distribution. Don't deal with the samples. Hereafter, don't deal with sample distribution. Prefer to deal with sampling distribution. So in order to visualize the sampling distribution, what you need is, you need X double bar and standard error. Why? Your X double bar will be very, very closer to your mu. Your X double bar, the chance of your X double bar becoming mu is extremely higher. Similarly, the standard error has a relationship with population standard deviation. Look at the relationship. Standard error has a relationship with population standard deviation. Standard error equal to population standard deviation divided by square root of n. You know what is n here? What is n here?
Sample size.
Sample size, the subgroup size or the sample size. So once you have the standard error and X double bar, it is very easy to predict your mu and the sigma. All right. So now you also.
Sir, could you repeat once again that the standard error is yeah,
X double bar will be equal to mu.
correct?
And the standard error will be equal to sigma divided by square root of n. And the symbol for standard error is sigma x bar. Sigma x bar equal to sigma divided by square root of n. Where what is sigma? Population standard deviation. What is n? The number
Sample
of
size.
sample size or subgroup size. Suppose in a scenario, you don't know what is population standard deviation. You only have sample standard deviation. Sorry. You only have sample standard deviation. In such a case, standard error can be calculated using this relationship. You know what is the relationship? Standard error is equal to sample standard deviation divided by sample size. You know why this formula is given? This formula is derived to minimize your effort of sample collection. To minimize your effort of sample collection, keep all this information in some corner. This will be extremely helpful. All of you understand whatever I explained right now? There are three types of distribution I explained. Can you name the three distributions?
Population
distribution,
distribution, sample distribution,
sampling
sample
distribution.
average distribution.
Wow, beautiful. Population, sample, sampling.
Sampling average distribution.
Here it is mu comma sigma. Here it is x bar comma s. Here it is x double bar comma sigma x bar. See, you can always use the sample to predict the population, or you can also use the sampling distribution to predict the population. Which one can help you better? Sampling distribution can help you better. You don't require more samples if you work with sampling distribution. Even with lesser sample size, you can predict, you can judge your population. That is the advantage of working with sampling distribution. There is a theorem I told you, central limit theorem. You know what is this theorem is telling you? The tendency of
Sample average to
sampling,
possible
sample average exhibiting normality is very high. It only depends on the sample size. That's all. If sample size of 2 is not helping you, go for 3. If 3 is not helping you, go for 5. At the maximum is 25. You definitely know within that you will be able to get a perfect normality. Once you get a perfect normality, and with the help of that, you can calculate X double bar, you can calculate standard error and everything. All right. So your understanding on the population can be more accurate if you work with the sampling distribution. Hope this particular knowledge is helpful to all of you. All of you, do you understand the stuff here? Imagine you have to you have only limited time to take the sample, but you still wanted to judge your population. Now, what will you do? You only have 1 hour. Let us say you only have 1 hour. Will you be able to study the entire population in 1 hour? Not possible, isn't it? So what you do is you go for a sample of, you go for a subgroup of 25 samples. You go for a subgroup of 25 samples. Now, with the help of the 25, you can find out sample average. You can find out sample standard deviation. And now the X double bar is nothing but X bar only because you have taken only one sample. Average of the average is X double, same only. And what is this? Yes. What is this? Yes.
Sample.
Sample standard.
Sample standard deviation. Now, sigma X bar. How to calculate sigma X bar? There is a formula, S divided by root of N. What is your S? Whatever value. What is your N? Since your sample size is 25. 25. See, how many sample you have taken? You have taken only one sample, isn't it? One set of 25 sample you have taken, but you have the X double bar value, you have the sigma X bar value. It is as good as taking a sample over a good period of time. Yes or no? Your X double bar is available. Your standard error is available. Now the entire sampling distribution is drawn. So, whenever you are running short of time, whenever you can't, collect too many samples and try to work with the sampling distribution. Try to work with the sampling distribution. Try to make use of the standard error. Right? The formula for standard error is S by root of N or sigma by root of N. Whichever is available, you can use. If sigma is available, that is most preferred. If sigma is not available, use capital S. Okay. So this is about the bell curve. And I also want you to understand one more thing. If I draw a bell curve, let us say I am drawing a bell curve of your performance in the examination. What do you think will be the average mark of all of you if I conduct an exam right now? Difficult question. What will be the average mark of all of you? You all know all your capability, right? You can look at all your faces and make some judgment. So what will be the average this class can produce?
80.
Okay, 80. So 80 is the average, sample average. And there will be a standard deviation, yes or no? What do you think? All of you will perform very consistently, or do you expect abnormal deviations also?
Yes.
Will you expect deviations?
Yes.
Yes, because you are not planning any group study, you are not meeting together, no? There is a good chance that, your standard deviation can be higher. Now tell me a standard deviation. Standard deviation, what can be a good standard, what can be the value of standard deviation for all of you? It will be 5. Let me say 5. Can you see a standard deviation of 5 here? So the maximum mark I can expect from the class is 3 standard deviation, which is 15. So 95. And the lowest I can expect is
75.
65.
Okay.
Do you understand? This is how your mark will get distributed. In order to judge this, I needed this and this. Do you understand? Once I have the class average and the class standard deviation, I can judge all of this. And now I am very confident that 99.73% of the class will be scoring between 65 and 95. Almost the entire class. Maybe one or two. One or two can fall below 65, one or two can fall above 95, that is possible. But the majority will fall here. Suppose if I choose some other value, let us say instead of 65, let me choose 70. And let me choose 85 here. Now, what percentage of the students will be falling between these two?
95 point.
Very good, 95.4. So, see here, just by having your, data, I am able to, understand the distribution. This is called normal distribution. This is a normal distribution, a realistic scenario. The real marks are used here, yes or no? 80 is a real average. 5 is a real standard deviation. Now, I very well know, please note, I very well know my black belt participants always have an average of how much? 80. And they will have a standard deviation of 5. This is my expectation. Now I have another batch. If another batch of students, they also get the same average. They also get the same average. That means the expected distribution is happening again. What is my expectation? 80, and my class is also getting 80. Is there a difference between the expected value and the actual value? No, expected average also 80. The actual average is also 80. That means the difference is 0. I can always see how this difference is, getting distributed. Do you understand? Right? So, suppose if the expectation is 80, but my next batch of participants have scored 85. Now, how much is the difference? 5. So, 5 is the difference. And of course, my standard deviation is also 5. So, the difference of 5 is equal to 1 standard deviation. Am I right? The difference of, that means, my 85 is here. Please note. And this distance is actually, see, this is 80. This is 85. This is equal to 1 standard deviation. Am I right? And similarly, this point will be 2 standard deviation. And this point will be 3 standard deviation. See, I want you to understand. See here, in this distribution, the center point is 0. Am I right? Somehow you transform the center of the distribution into 0. And standard deviation equal to 1. See, earlier, what was the standard deviation? Standard deviation was 5. Standard deviation was 5. But as far as this distribution is concerned, the average is 0. And the standard deviation is 1 standard deviation here, 2 standard deviation here, and 3 standard deviation here. But what is 1 standard deviation? Standard deviation is 5, 1 into 5 is 5. Do you understand what I'm telling here? So, if you talk about a distribution with average as center and standard deviation as 1, this distribution is known as standard normal distribution. Do you get my point, all of you? Please note, I draw a bell curve. This is 80 and this is S equal to 5. Normally, this is written as normally distributed. Just a second. Yeah, this is normally written as normal distribution with 80, 5. When I write like this, it represents a normal distribution with average of 80, standard deviation of 1. Suppose if I write like this, it represents a normal distribution with average 0, standard deviation 1. Now, this is a case of normal distribution, whereas this is a case of standard normal distribution. Do you understand what I'm telling? Standard normal distribution means the average is transformed to 0. The average of the distribution is transformed to be 0, and the standard deviation of the distribution is transformed to be 1. If the average becomes 0 and standard deviation becomes 1, then the distribution is considered standard normal distribution. Why this standard normal distribution concept is coming? See, if I am dealing with the test marks, the mark will become a bell curve, isn't it? I will have average, I will have standard deviation. I can write the rule 68%, 95%, 99% and everything. Suppose if I come to your company, will you also be dealing with marks? In our training institute, we are dealing with marks. But when I come to your company, you will be dealing with the real products, yes or no? Anyway, from your products also I can generate data. From your product also I can generate data. So my bell curve cannot be, the bell curve of the marks cannot be used to study the bell curve of your products. So to overcome this, what I do is I go for a standard bell curve. Standard bell curve, the center will be 0 and the standard deviation will be equal to 1 standard deviation here, right? 1 standard deviation, and this is 2 standard deviation, and this is 3 standard deviation. So this is known as standard normal distribution. Here the property will exactly, be same, 68.27, 95.45, 99.73. Once you understand any bulk curve, the property is applicable, you can expect the normal distribution properties to be followed in your data also. Do you understand? The property of normal distribution not only be applicable in the test marks, the normal distribution properties will be applicable in manufacturing data also. The normal distribution property will be applicable in service industry data also. The only requirement is the data must be a continuous data. All of you understand? If I calculate, if I record all your sugar levels, blood sugar levels, that will exhibit normality. Yes or no? All your height, all your age, everything, will exhibit normality. So definitely this piece of knowledge will be helpful to make judgments and to describe any performance by once you have a data in your hand. All right. Okay. So now, any questions you want to ask at this stage? There are 3 types of distribution I have explained you. Population distribution, sample distribution, and sampling distribution. The main purpose of discussing about the 3 types of distribution is to give you enough confidence that normal distribution property can be applied in all industries. The only thing you need to take care is please work with sample averages, not with individual samples. Because the risk will be very high if you work with individual samples. The risk will get minimized if you work with sampling distribution. If you are running a hospital and if I come to your hospital, suppose you are running a project to reduce the turnaround time. Turnaround time is a continuous data, isn't it? Turnaround time is a continuous data. So the normal distribution properties can be, readily applicable with the help of the data of turnaround time. All right. So now the next important thing is validating our measurement system. Earlier we understood that we can perform a study known as gauge R&R study, isn't it? Earlier we performed, we talked about gauge R&R study. In gauge R&R study, what are we concerned about? We are concerned about the gauge repeatability and gauge reproducibility. So now let's try to understand the what to say, the critical plan to conduct a gauge R&R study. So for that, I'm just opening a Minitab screen. So let it open, but I will start telling you the requirements to make your gauge R&R study more effective, right? First requirement, you must minimum include 10 samples as part of your gauge R&R study. How many samples?
10
10
samples.
samples. So I will, now I'm showing my Minitab screen. See here, gauge R&R study plan. Samples. I mean, 10 sample parts you must include. You must include 10 sample parts. How? Covering the range of dimension. Covering the range of dimension. Suppose, let's say you are dealing with the length of a product. The required length is 100 plus or minus 0.5. Now, what is the lowest length possible? What is the lowest?
99.5.
Yes. And the highest is
100.5.
100.5. And now you have to choose 10 parts covering the range from 99.5 to 100.5. Do you understand? 90 from you no need to take parts below 99.5 and you no need to take parts above 100.5. All your 10 parts should be within the range. Clear, all of you?
Yes.
And when you select 10 parts, make sure 5 parts are selected below 100 and another 5 above 100. Do you understand? I want you to keep your samples symmetrical. This is how you must plan. And another thing is 60% of your samples should be good parts. That means 40% of your samples can be bad parts. Do you understand what is a good part and a bad part? Good part means the measurements are closer to the target. You know what is the target?
100.
Very good. Keep 60%. 60% of 10 is how much? 6. 6 parts should have the value very close to 100. And remaining 40% of the samples should be close to 100.5 and 99.5. Can you understand? This is how you must select samples. You as a MSA study, you as a assessor of the measurement system, you should only know all these piece of information. You should not reveal it to others. It should be a secret known only to you. Clear, all of you? And now you have to select appraisers. Who are appraisers? You know who is an appraiser? The data collector, right?
Correct.
The person who is collecting the data. And now, right now in the training program, there are 17 people in the training hall right now. In my project, I will include a maximum of 3 people for data collection. But how many people are there in the project team? 17. Now, who will be involved in the data collection? Suppose you know who are the 3. The same 3 people can be included in your gauge R&R study also. This is a sample data collection. All of you please understand. What are we planning right now? We are planning for a sample data collection. The actual data collection will start after ensuring that our measurement system is good. Now, appraiser selection, you can make it in a random manner. In a random manner. If you think all of us are equally good in data collection, then you can go for a random selection. How can we select 3 people? Random manner. Suppose you have some other criteria. Let's say I will only use Sadashiv, Vyas, and Naragyadas. They are the data collector in my project. Then in my sample data collection also, I will include them. If there are too many people available, then I have no other option other than randomly selecting 3 people. Clear, all of you? Now, every experiment of data collection must be replicated at least twice. Why is this statement? Why am I typing this statement? Every experiment of the data collection must be replicated at least twice. You know why? To check the repeatability of the appraisal. Am I right? Otherwise, you will not be able to understand whether the operator is collecting the data consistently or not. That you will not be able to understand for that. All right. So these are the requirements. Now I will show you the procedure in Minitab. Go to Stat, go to Quality Tools, go to Gauge Study. Right? Stat, Quality Tools, Gauge Study. And now there is an option to create your Gauge R&R study worksheet. You click that. And now it will ask you number of parts. What is that I told you? Minimum how many parts you should have? 10. You want to have 15? That's well and good. You want to have 20? That's extremely good. But minimum 10.
10.
Because more the experiment and more will be the time, effort, and money. And number of operators can be 1, 2, 3, and depending on the condition. But if there are 2, then only the reproducibility can be estimated. Minimum 2 operators are required, then only reproducibility can be estimated. Similarly, replication should be minimum 2, then only repeatability can be estimated. So I am going for 3 replication. 3 is better than 2, right? And operator also 3. And operator name also I can give here. I can say I will use Sadasiv and I will use Vyas and I will use Ashim. Now these are the 3 operators I have. And 10 parts, and I can have 1, 2, 3, or I can have A, B, C, D, and all. And now 10 here, 3 here, 3 here. 10 into 3 into 3. How much is the value?
90.
So minimum 90 readings must be generated. You have to conduct 90 experimental trials and 90 readings you need to generate. Once 90 readings are generated, you can analyze and understand the Gage R&R value, right? Already we discussed about Gage R&R. Now I give OK. Now the Gage R&R worksheet is created. Can you see here, all of you? Can you see how many rows of data generated here? 90
90.
rows. Now each row is a trial. The first trial is Sadashiv will be checking part number 3. Sadashiv will have a vernier caliper. He will pick up part number 3 and he will be measuring. And that reading must be recorded here. Let's say his reading is 100.05. The equipment resolution is 0.01. So 0.0, so 2 decimal is coming. Now what will be the next trial? Sadashiv will now go to part number 1 and measure part number 1. The reading is 99.85. Do you understand? In this manner, he has, you have to complete all the trials for Sadashiv and then Vyas and then Ashim. Again Sadashiv for the second time. Vyas, Ashim, again Sadashiv. Because we planned 3 replication, no? So each appraiser or each operator will be measuring each part 3 times. Once these readings are available, you can actually perform the analysis and then estimate the gauge R&R value. And so let me pick up a sample data here. File, open worksheet. I click this and I just type Gage here. So that the second file name, Gage AIAG.mtw is the one I want. I use this and open. So yes, it has to open. So I give OK again. Can you see here? Part number, operator information available. Data is also available. Similar scenario, 90 data. So, but in reality, you have to conduct the experimental trials and generate the data. But here I just picked up from the sample project. So now what should I do is I should perform the analysis. So go to stat, go to quality tools, go to gauge study, then you see gauge R&R study crossed. The study is considered crossed because the same 10 parts are measured by all the appraisers. So the study is known as crossed. So you select that. Now come here, part number. Where have you typed the part number? In column number 1, under column number 1. Click and select. Where have you typed the operator details? Column number 2. Click and select. Where have you typed the actual data? Column number 3. And now any method you can use for the analysis, and X bar R is easier. And then you have to go to these options. It's very important to declare the lower spec and upper spec. During the discussion, I told you lower spec is 99.5, upper spec is 100.5. But however, this data is not for 100 plus or minus 0.5. This is some other inbuilt in Minitab. So I don't know what is lower spec and upper spec. So randomly, I'm going to declare the difference. Because that is important. The difference between the upper spec and lower spec. What is the total tolerance given by the customer? Let me say the total tolerance given by the customer is some value 12. With respect to the tolerance given, how much is the measurement error? Is it less than 10% or more than 10%? That is my concern. So you give OK, and then you give one more OK. Now Minitab will take care of all the calculation and generate this kind of graph. How many graphs you see? 1, 2, 3, 4, 5 and 6 graphs. If you read all the 6 graphs carefully, you will be able to pinpointedly point out the source of error. Whether our Sadashiv is troubling us more, or Vyas is troubling us more, or our Ashim is troubling us more, I can find out. But I should be very good at reading the graph. I'll come to that with my slides. And now go to the session window. Go to the session window. As you already know, there will be 2 tables, right? The first table you need to skip for now. However, the first and second table gives more or less similar information. Now go to the second table. See here, there is a row talking about total gauge R&R.
If you can
What
do
is the total
something,
gauge
do
R&R?
it
Come to
alone.
the last column, 15.29.
29.
That means your measurement system is
पता नहीं अभी सच्ची में मेरे को लग रहा है कि
measurement system is conditionally acceptable. What is the meaning of conditionally acceptable? Look at the tolerance given by the customer. If the customer has given a very wider tolerance compared to your process, then 15% is also okay. If the customer has given you a very narrower tolerance, let me, change the scenario. Go to stat, quality tools, gauge study, gauge R&R study, crossed. And after giving data, you go to option. Let us say, the customer has given a wider tolerance. Okay. So tolerance I have changed it to 24, right? I doubled it. And now in this scenario, either the gauge R&R will automatically drop even if the gauge order is higher, you still you very well know that the customer has given a wider tolerance. In that case, even 10 to 30% is also acceptable, right? But going to the previous scenario is here, right? 15.29 is conditionally acceptable. And you know how to make a proper decision here in a conditionally acceptable scenario? For your process, you know the control limit. Yes or no? And the customer has given you the specification limit. Just check whether the control limits are closer to the spec or well inside the spec. If control limits are well inside the spec, then 10 to 30% is also okay. Do you understand? If control limits are closer to the spec, then it is better to avoid using the same measurement system. We have to go for a better measurement system because the uncertainty created by the measurement error can lead to wrong decision. A good product might get rejected or a bad product might get accepted. All these possibilities are higher. So, but any value of gauge order less than 10% is your measurement system is considered acceptable. But any measurement system with a gauge order value of more than 30% is unacceptable. All of you agree with me on that? Less than 10 acceptable, more than 30 unacceptable, but 10 to 30
Conditionally acceptable.
conditionally acceptable. Now, how to check the condition? Compare the position of the control limit with respect to the
Spec.
specification limit.
Yes,
With respect to
specification
the
limit.
specification limit. All right. So now what will I do? Give me a minute. I will share my screen and using which we will try to understand we'll try to understand all the graphs. We'll try to understand all the graphs. So let me share my complete screen. Go to the folder. Yes, folder. And now module 2. Module 2 is measure phase. Yes, it has come. So these are the conditions. Yep. Yeah. This is the condition. But I said I will show you the graphs, right? So let me get something different. Gauge R&R. Yes, this is the one. Yeah. Can you see my slide showing all the 6 graphs?
Yes.
Yeah. Yeah. Okay. So each graph can give you a piece of useful information using which you can understand where exactly your measurement system is going wrong. Whether any particular operator is troubling you or any particular part is troubling you, right? And all that, you will be able to understand whether repeatability is the issue or reproducibility is the issue, which is dominating. So look at the first graph. You see now it is a bar chart. Am I right?
Yes.
It's a bar chart and there are 3 colors used. You need to understand. If you know the upper spec and lower spec, or if you have typed the difference between upper spec and lower spec, you must use yellow color bar. Only in the event you don't know the upper spec and lower spec, you must use the red one. You must use the red one. Do you understand? If you have not typed the upper spec, if you have not typed the lower spec, you have not typed the difference between upper spec and you don't have any clue about customer tolerance. In that case, only you should use the red one. In all other case, the yellow one. See, in the Gage R&R report, I asked you to skip the first table, right? The blue color graph is meant for the first table. So right now, don't worry about it. I'll talk about it maybe at a higher stage. So now I am removing both the red as well as the blue. That means you need to look at only the yellow. Now look at the yellow graph. What do you understand? What is this bar represents? Can you tell me what is written here?
Part to part.
Part to part variation. That means this is the real process variation. But what is this? Gauge R&R. If the gauge R&R is the problem within your measurement system. And this part to part variation is the problem you want to fix. If you want to fix, can you have a measurement system with this much problem? That is, that is the thing you need to consider. And AIAG guideline is, it should be less than 10% of the tolerance given by the customer. All right. Now see, this Gauge R&R is broken down into repeatability portion and reproducibility portion. Which is taller, the repeatability part or the reproducibility part?
Repeatability.
Oh, that means, the repeatability error is dominating in your measurement system. This is the information you can understand from the first graph, which is nothing but a bar chart. Clear, all of you? Now moving on to the next. This is a R chart. R chart means range chart. Range is the representation of repeatability of the operator. If you are poorly repeatable, your readings will have too much variation, yes or no? If your readings will have too much variation, then the range will be higher. Now look at this graph. Whose range is higher? Operator 1 range is higher, 2 is higher, or 3 is higher? Comparatively, who is higher? 1 or 2 or 3?
One.
One.
1 seems to be on the higher side, right? Because you see the range of 1 is moving away from the center line. And who is extremely consistent? 1 or 2 or 3? I mean, who is more repeatable? 1 or 2 or 3? The less repeatable, you found out 1. And who is more repeatable?
2.
2. So who is good and who is not good? This graph is letting you understand. Yes or no?
Yeah.
So if at all any action needs to be taken, that should be with operator 1. Maybe you train him, provide him some extra training or check what is specifically going wrong with operator 1, and then the repeatability part can come down. At the same time, looking at the operator, the readings of the operator 2, as a statistician, I am doubting his readings. You know why? It is going like a train. Can you see here? Train coach. This is against normality, isn't it? In a normal, in any natural process, data must get distributed randomly. But here, it is going like a straight line. This is against the natural way. Any data collected in a natural manner will have some variation. I am not able to see any variation with him. I doubt whether he is biased. Maybe he is afraid of the study. And that's why I told you, don't reveal certain things to the data collector also. Don't even let them know that you are assessing them. You should not reveal anything. Just ask them to work casually, and so that the human bias element can be prevented. So all of you understand how to use this graph, R chart? Now you move on. Now you move on to X bar chart. Now tell me, what percentage of good parts are mixed with bad parts? 60% good, 40% bad. Yes or no?
Yes.
If you have 60% good parts, 60% of your readings should be closer to the center line. and 40% of your readings should actually fall outside the control limit because you purposely selected those 40% of the parts closer to the spec. Yes or no? So 40% of the points should fall outside the control limit here in the X bar chart. If that is not happening, you can understand your measurement system is not able to discriminate between good and bad. Whatever ratio you maintain, that should appear here. 60-40 means 60% should appear inside, 40% should appear outside. Or if you change the ratio, accordingly the change should appear in this X bar chart. All of you understand how to use this X bar chart? This is very tricky. Please note, conducting a Gage R&R study, you have to have a thorough understanding. You have to plan everything and then expect a data accordingly. If data is not coming as per the expectation, you can judge there is something wrong with the measurement system. This is called measurement system validation procedure. Now, what is this? Part-wise response. How many parts you selected? 10 parts. And every part measured by 3 operator, 3 times each. 3 operator, 3 times each. Every part will generate 9 readings. But all 9 readings are generated from the same part. That means all 9 readings, you can expect them to be same. But actually in reality, look how your measurement system is generating. Look at that part number 10. Are you getting same readings 9 times? Can you see a higher spread? This is an indication of poor reproducibility, and the source of the poor reproducibility is part number 10. Your people are struggling to measure part number 10. I don't know, it is closer to the spec or closer to the target that you need to figure out. But part number 10, your team is really struggling. Where is your team doing well? Part number 6. Can you see your team doing well with part number 6 and 7? 6 and 7, they are handling well. And 10, very poor. And all other parts also, I see abnormal variation. So which particular part your team is struggling? That piece of information is coming from this 4th graph. And now what is the corrective action you can do here? Explain the procedure of measuring part number 10 to all your team members. If everybody aligns, the reproducibility, the variation will come down. This graph is known as box plot. How many box plot you see here? 1, 2, and 3. Now the box plot 1 represents the data produced by operator 1. This refers the data produced by operator 2. This refers to the data produced by operator 3. Operator 1 measured all 10 parts 3 times, totally 30 readings. 30 readings are used to generate this box plot, another 30 for second box plot, another 30 for third box plot. In the box plot, there will be 3 lines, one bottom line, one center line, and one top line. The center line is nothing but median. What is median? The point that divides your data equally. 50% of the data will be below the median, 50% data above the median. And this circle with the plus symbol, this represents the average. Average of the 30 reading is marked here. Average of the 30 readings of operator 2 is marked here. Average of the 30 readings of operator 3 is marked here. If all of them are properly reproducible, all the 3 average are expected to be in the same horizontal line. If they are not reproducible, you see the ups and downs happening with respect to the average. Now tell me, who is actually pulling down your data? Is it 1 is pulling down, or 2 is pulling down, or 3 is pulling down? Where is the average different from others? Is it 1 different from 2 and 3, or 2 different from 1 and 3, or is it 3 different from 1 and 2? Which average is different from the other 2?
Two different
2
from one and
is
different
2
from
is
1 and 3.
measuring differently. from 1 and 3. If all the three follow the same way of measurement, all their average will be on a perfect horizontal line. Now we could easily make out 2 is placing his average, far below the average values of 1 and 3. And so you have got something to do with operator 2.
So, but in this case, we do not have a median for operator 3, right?
Operator 3 median can be drawn, It is not marked. It can be drawn. It is just missing. It can be drawn. And but the point, since the discussion is limited only to average, and that is not coming here, otherwise it can be drawn. And so you have to probably train your operator 2. But see, there are two possibilities. Either 2 is differing from 1 and 3, or maybe 2 may be correct and 1 and 3 is differing from 2. Both possibilities are there. But here we actually don't check the correctness. We check the consistency only. We check the precision only. So any of the action, will do. Maybe the 2 can be advised to measure properly so that his average also comes in line with the other. If you make that happen, the reproducibility error will fall down. And finally, there is something known as interaction plot. Are there any particular operator behaving dynamically? What is dynamically? See, if there is any error in the data, the error should always be on one side, isn't it? Sometimes he puts the error on the positive side, and sometimes he put the error on the negative side. That operator is considered to be a dynamic behavior. That behavior is known as dynamic behavior. You see here, blue color, red color, and green color. The blue dot represents the readings produced by operator 1. The red represents operator 2. Green represents operator 3. And see, all of them have measured the same thing only, but the blue color one, is on the higher side. Can you see here? And the green is on the lower side. But when it comes to the part number 2, the behavior is different. Now green appears on the top. Can you see here? This green was giving, the lower readings as far as part number 1 is concerned. But then for part number 2, his readings are, higher. Now you could understand there is some kind of dynamic behavior being demonstrated by operator 2. This is known as interaction. Whenever interaction is happening, you can see the lines crossing each other. Can you see the green color line crossing the blue and red? But similarly here, from 2 to 3, the blue color line is crossing. Again, where is the interaction? Here, from 6 to 7, do you see interaction here? Who is actually behaving dynamically? Operator 1. So we don't want anybody to behave dynamically. We want a stable, consistent, measurement of the data. We don't want any favor or, what do you call? We don't want you to favor us with the reading. At the same time, we don't want to, harm our readings. Just you measure accurately. That's all. And we want consistent reading, which is what we call it as the precise readings. Clear, all of you? How to read the 6 graphs?
Yes, sir.
Yeah. So if you take these kind of actions, definitely you will be able to control the gauge R&R value, and hence the measurement system becomes acceptable. These kind of actions are required. Right actions can make your measurement system a better one. Or if you don't know how to perform all of this, then the only option is you have to buy a new measurement system. Isn't it? So those are the only two options. Either you improve your existing measurement system. Only for improvement, you must be able to read all the graphs and then to take the right action. Another way of fixing the problem is change your measurement system, right? So that's the point. And now just allow me another 5 minutes and then I will leave you for the day. What I want to show you is the Excel template. Using the Excel template, to calculate the CP-CPK metric. You can see my Excel file now, and there is a sheet. There is a sheet known as CP and CPK. Can you see here CP, CPK?
Yeah.
Please note CP and CPK. CP and CPK. C means capability. C means capability. P stands for process. That means these are nothing but measures of process capability. In general known as process capability indices. And out of the two, the CP is known as process capability ratio. CP is known as process capability ratio, and the CPK is known as process capability index. All right. See, one is ratio, the other one is index. And which is better? I'll tell you CP. Okay, where am I typing? Yeah, I'll tell you. Okay, I'll type here. So CPK is better because for calculation of both the CP and CPK, we need certain values. You see here, upper spec is required, lower spec is required. And then process average or mean. Process average or mean. You can also, yeah. Process mean means process average. Then standard deviation. What standard deviation? Process standard deviation. Process standard deviation. Once these values are available, you can calculate CP, you can also calculate CPK. Please note, I hope you all remember, when your process is doubly capable, CP, CPK will be equal to 2. When your process is just capable, CP, CPK value will be equal to 1. So, the requirement, the industry standard is, I'll tell you, the industry standard is, okay, let me type here. The CP should be more than 1.67. Your CPK should also be more than 1.67. This is industry standard. Both your CP and CPK should be more than 1.67. CP as well as CPK should be more than 1.67. Suppose if your process is not so much critical, then 1.33 is also okay. 1.33 is also okay. Now imagine you are running a process. Let us say it's a coating process. Customer requirement is 50 micron thickness of coating. 50 micron thickness, and customer given tolerance is plus or minus 3 microns. Now, what is your upper spec? 53. The lower spec will be 47.
47.
And now I want to know with respect to the customer given tolerance, with respect to the customer target, what is the customer target here? When I say upper spec 53, lower spec 47, the customer target is
50.
50. So with respect to the target and specification provided by the customer, how is your process performing? To know that, you have to pick up some samples. Yes or no? You have to pick up the sample. Once the sample is picked up, the average can be calculated, standard deviation can be calculated, and so entire distribution can be visualized. You understand? Let me just draw this scenario in a whiteboard so that you understand what exactly I am talking. So all the discussion we spoke today at the time of starting of the session. Okay, first let me write. Okay, the target is how much? 50. Upper spec is 53. And the lower spec is 47. Now the customer requirement is indicated with the 3 lines. And now how is your process performing? Now, in order to understand the process performance, you should Find out the sample average, because sample average is a representative of the process center. Yes or no? Let's say sample average is also 50. Then sample standard deviation. Sample standard deviation is a representative of the spread of the process. Right? The sample standard deviation, let us say it is, some value, 0.8 or something, whatever. And now, since the sample average is right on the customer target, your process is centered effectively on the target. This is how your process is operating. Can you see here? The process is operating like this. Its lower control limit is somewhere here on the left side. Upper control limit is somewhere here on the right side. But can you see both the control limit inside the spec? That means this process is capable. Your CP will be more than 1. CPK will also be more than 1. All right. Suppose average is not 50. Average is not 50. Average is 51.5. What happened now? Your process is shifted. Can you see that? Your process is shifted to the right side. But standard deviation wise, the same value. Spread is okay. But process is shifted to the right side. Now you will see your process operating in this manner. Do you think your process is now capable?
No.
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 So many rejections are happening. Only to judge whether the process is shifted or not, we introduce another metric, CPK. In the formula of CP, only the standard deviation is used. However, in the formula of CPK, both the X bar and sigma, both are used. That is why I told you CPK is a better measure of capability. Now, with this piece of additional understanding, let us go to the Excel sheet and type down the sample average and this thing. Look at the sample average. What is the sample average here? How much it is? Can somebody tell me? 49.88. 49.88. Tell me, is it closer to the target? Very close.
Yes.
You should be happy about the place where your process is operating. Your target is 50 and your process is very close to it. Please be happy about it. And now the standard deviation. Standard deviation is 0.83. How much tolerance you have on the right side? 50 plus 3. Yes or no? And but your process sigma is how much? 0.8. We very well know easily our process can go up to 3 standard deviation. Yes or no? 3 standard deviation, 0.8 into 3 is 2.5. But how much tolerance customer is given? 3. Luckily, since your process is operating exactly around the target, the situation still not very harmful. So the moment you type these two values and press the enter button, the CPK values are generated. Can you see here? CP is more than 1. CPK is also more than 1. The process is considered capable. But however, is it meeting the industry norms, industry standard? No, because the industry standard is 1.67. See, just having, just meeting the customer requirement is not enough. You should be able to exceed the requirement, right? Because in a long run, easily things can go wrong. The situation may not hold the same manner tomorrow, but we will be producing continuously, isn't it? So you must target.
Sir, could you repeat that sigma within that how that is derived? 0.83 means.
Yeah, sigma within. See, sigma, if you ask me the question, sigma within. Sigma within is nothing but the standard deviation within your samples. The standard deviation within your samples. Let us say your sample size is 20. Your sample size is 20.
20.
And will there be a variation within the 20 samples? Will there
Yeah.
be a variation within the 20 samples?
Yes.
Even though you picked up all 20 samples simultaneously, same time you picked up 20 sample, then also there will be variation. That variation is known as within variation. You calculate standard deviation using the sample data, which is known as within sample standard deviation,
Okay.
right? And that should be used here, 0.83. And now 1.2, 1.15 looks capable, but practically industry norms is 1.67. Even in the worst scenario, minimum 1.33 needed. So right now, this condition of the process is unacceptable in any industry because it is not meeting both the criteria 1.33, 1.67. Suppose the characteristics you deal is the critical characteristics, 1.67 is definitely required. Now let me change the scenario. Now what am I supposed to do now? What should I focus on now? Should I focus on shifting the average or focus on reducing the variation?
Reducing the variation.
Very good.
Variation.
So 0.8, let me reduce it to 0.63. The scenario is changing. CP improves, CPK also improves. Please note, when I reduce the variation, you see improvement in both CP as well as CPK. Now, I'm going to do one more thing. Even though the shift is very, very small, I'm going to correct it. Now, where are you noticing the improvement?
CPK.
The improvement is seen only in CPK, right? Because any improvement with respect to the sample average will affect only your CPK. Because CP doesn't care about the sample average. CP doesn't care about the process average. But CPK takes into account the process average and the process spread. Both are important. That is why I told you CPK is the best measure of capability. In this case, maybe let me reduce the value a little more. I reduce the variation further. Both my CP, CPK are more than 1.67. So my process is declared capable. My process is declared capable. Suppose I don't have the CPK value. I don't have the CPK value. I only have the CP value. Then don't be, so fast to conclude the capability. If you look at CP, please decide only about the consistency. If CP is good, process is consistent. If CPK is good, the process is capable. So please use the word capable or declare the process capable only after getting sufficient CPK value. If CPK is okay, you can declare the process capable. If CP is okay, you can declare the process consistent. And see, if CPK is under trouble, two actions are required. See here, let me damage the process now. And variation I am increasing. Can you see your CPK is under trouble? I am shifting the process from 50 to 48.5 or right side 51.5. Can you see your CPK getting into further trouble? So whenever your CPK is under trouble, two actions are required. What are the two actions? You have to shift the process towards the target. 51.5 is shifted to 50. Can you see an improvement in the CPK? And one more action is reducing the variation. 0.93 is reduced to 0.53. Can you again see an improvement in CPK? So whenever your CPK is under trouble, how many actions are required? Two actions. One action is shift the process. Another action is reduce variation. Shifting the process is sometimes referred as moving the mean. You have to move the mean as well as you have to reduce the variation. If your CP, if your CP is very good, see here your CP is very good, 1.88. But CPK is unacceptable. That means only the process is shifted to 52. Now what is the scenario? CP is acceptable. CP is acceptable, isn't it? Only CPK is unacceptable. Now, what is the action required? You have nothing to do with the variation. Variation wise, it is very good.
Move
What
the
is the
mean.
problem?
Move the mean.
Move the mean leftwards. Move the mean, process mean from 52 to 50. 50 is the target. Now your CPK will also improve. So these are the two things you need to take care. Two improvements: moving the mean and reducing the variation. Suppose imagine we keep the pass mark as 80%. And I conduct some mock exam for all of you, and I realize the class average is somewhere around 55. What happened to my average? My average is shifted to the left side, isn't it? Normally, I see the students' average above 80, but this particular batch, I see the average below 60. My average is shifted now. Now, how can I reshift the average, or how can I move my average towards the target? Tell me, what should I do to move the average from below 65 to above 80? What should I do? Come on, suggest me. Suppose if this happens in our training program itself, I have to consider conducting some extra sessions.
Strengthening the training.
Yes, I have to give you, orient all of you towards the exam in a better manner. That's why, we are going to conduct an extra session this week onwards for all of you. Right? Thursday, hereafter, all Thursdays, you will have a session, extra session, a complimentary session, exclusively on examination questions. Right? You will be introduced to a new faculty and a senior person who is very strong in statistics, and he can throw better light on exam questions and statistics, plus any specific doubt you people will have. The meeting ID and everything will be shared in the WhatsApp group. It is purely optional and it will not be recorded. But if needed, a similar old recording can be shared, right? But it won't be recorded because it is full of interactive things. So one thing is conducting extra sessions can shift the average, and giving you extra mock exams can shift the average, yes or no? And providing you some additional templates to handle different analytical problems. So these kind of actions can help you to move the average towards target. All of you understand?
Yes.
Sometimes what happen, variation, how can I control variation? I want all of you to score around, the targeted value only. I don't want the students to score different marks. I want everybody to score close to each other. What can I do now? How can I bring the consistency here? First of all, I will make the attendance compulsory. Yes or no? Simply because few participants are not, attending all the sessions. They are underperforming, or sometimes, they perform, extremely better. In order to bring the consistency, the attendance must be made compulsory. And I need to encourage a lot of group study, sharing of knowledge. All of these things, what will happen? Will reduce the variation. Do you understand? So you have to think, in a very practical way to make improvements in the process. Either you may have to move the mean, or you may have to reduce the variation. If you do that, both your CP/CPK will improve. Once you are able to improve the CP/CPK, your process will become failure proof. No failures, will happen in your process simply because you are maintaining a healthier CP value, CPK value. So these are known as process capability indices. This has got, the indices depends on USL, LSL, process average, and the within standard deviation of the process. Clear, all of you? And CP/CPK can be used in whenever you are dealing with the continuous data. Only when dealing with the measurable characteristics, CP/CPK comes into picture. Though it is very popular in manufacturing industries, it can be used in any industry where you are dealing with continuous data. That's all. All right.
Yeah.
So this completes, our today's agenda. And please go through the material also. There are some additional examples included in the material. And you also bring about any new challenges, new problems for discussion, and we will be happy to assist you. And in one book, an example about a hotel manager using the CPCPK index is also included in one book. A hotel manager using CPCPK. Because the food items should be maintained at a particular temperature so that customer satisfaction is ensured. Yes or no? If you go to any restaurant, the food should be at an optimum temperature. So temperature is a measurable characteristics. The ability of the hotel to retain the food temperature, during the lunch time, during the dinner time, and during the breakfast time is considered the capability, and they have used the CPCPK to maintain the capability of their process. So likewise, it can be used in any industry. Okay, so that's it from me for today. If there is anything you wanted to ask about CPCPK or any of the topic we dealt today, please ask.
So
And
in
I
the
think
Excel that
already.
you worked the CPCPK values,
Mm,
I saw some formulas for, some descriptions for the CP and CPK, like process range minus spec range. Could you just brief a little on that?
oh. This one, no? Oh, CP equal to specification width divided by process width, right? Because
Yes.
CP is a ratio, specification is the size of the road.
Okay.
Process width is the spread of the process. Spread of the process denominator is always 6 sigma. This is always 6 sigma. And the specification width is always USL minus
SL
LSL.
minus LSL. Okay.
That's all. So USL minus LSL divided by 6 sigma is the
6 sigma.
formula for CP. But there is a limitation with the formula. Nowhere the process average is considered. We are only checking whether the car is smaller than the road or not. If this is not enough, you should have a proper driving skill also. Yes or no? If the car is smaller, does it mean you will drive properly? Your driving skill is also important. Your driving skill is represented by X bar. So X bar is taken into account for calculating CPK. We divide, see, for that purpose, we use some logic. We divide the complete tolerance into 2 off. Similarly, we divide the process also into 2 off. So the process spread will become 3 sigma only, because 6 sigma is divided into 2 off. So process spread will become 3 sigma. Similarly, the tolerance, will also be divided into 2 parts. The right side will be the difference between USL and center. The left side will be difference between LSL and center. So we find out the ratio. USL minus X bar divided by 3 sigma. Another thing is X bar minus LSL by 3 sigma. We expect both values to, come equal. If they are not coming equal, it's an evidence that process is shifted. So using that manner, we find out whether the process is shifted or not. And that is why CPK will be going down whenever I shift my process, right? 50 to 51, whenever my process is shifting, CPK will drop. And that immediately to warn you that the driving skill is not up to the mark. And so we have to improve. The car must be driven at the center of the road so that you have enough cushion on the right side, enough cushion on the left side. If you don't understand this logic and drive it on the left side only, then the chance of hitting the obstacles on the left side will be more. So rejections will happen on the LSL side. So that is the logic. So don't worry, these the same things are taken care in this template also. And you can, however, it's a good idea to read further on CPCPK and then get your doubts clarified. That's a good question.
Thank you, sir.
Okay, anything else? I've already delayed your sleep today by more than 30-40 minutes. So I don't want to trouble you much. Yeah.
One request. So is it possible to get the recordings by tomorrow so that
Monday.
being a Sunday, we can just go through before the class?
No. That is, Sunday, being a Sunday, the same is the reason. Being a Sunday, we will not be able to upload it. And our team is, on leave. So Monday only they'll be uploading it. But don't worry, you can meanwhile manage with the materials, the PDF materials. Or otherwise, all of you can subscribe to my channel. I have a YouTube channel, Six Sigma with GSK. Maybe I'll share it in the WhatsApp group also. You can find content similar to the topics. Simply type CPCPK. You will find the thing, and the similar recordings will be available. You can temporarily make use of it, but that won't be the exact session. But a similar lecture will be available.
Sure.
All
Thank you.
right. Okay.
Yeah.
So thank you all of